Hi guys, welcome back here at DEC Engineering Tutorial. So, we will just continue our discussion on basic soil water relation. Okay, so punta tayo dito sa example 1. So, we have this loam soil having a field capacity of 25% and a wilting coefficient of 10%. And the dry unit weight of the soil is 1.5 grams per cc. So if yung root zone depth natin is 60 centimeter, so ano daw yung storage capacity nung soil. So provided that the irrigation water is applied when the moisture content falls to 15%. So bali given yung FC natin which is 25%, given yung PWP, the permanent wilting point, which is 10%, given din yung dry density which is 1.5 grams per cc and the root zone depth na 60 centimeter. And we have this given na OMC which is 15%, no? The optimum moisture content. Okay, so bali ito yun, no? So we have this field capacity at this point, 25, and then we have this OMC na 15%, no? So bali yung difference nung dalawa, yung 25% minus 15%, yan yung readily available moisture content. So ito yung minamanage or ini-extract nung plant, no? Without stress, no? Like madali lang i-extract nung plant to. We have 10% as a REMC. So, given din yung PWP, the permanent wilting point, which is 10%. So, bali, yung total natin dito, yung 25 minus 10, so we have 15, no? And then we know this is 15%, this is 10%, so bali, yung not available na moisture content is 5%, no? So, bali, ito yung under stress na yung plant roots natin, no? Kung mag-i-extract. Then, dito, below 10%, ito na yung hindi talaga ma-extract ng plant, no? Due to adhesive force nung soil. So, bali yung available moisture content natin is just 25 minus 10. So, we have this 15%. So, bali, in terms of depth naman, so we have this dry density over density of water, which is 1. We have the root zone depth, which is 60. And then we have this tau, no? The total available water content, which is 15%. So, in cm, we have 13.5 centimeter. And yan na yung sagot. Okay, so when the moisture content falls to 15%, the deficiency of water depth created will be given as follow, no? So bali kung gusto nating i-solve yung equivalent depth ng readily available water, so again, using this formula, we have 1.5 divided by 1 times the root zone depth, which is 60 centimeter, plus yung available, readily available na water content na 10%. So in depth, that is 9 cm. So yung 9 cm depth ng water is the net irrigation requirement. Another example for the base crop of a particular crop, so given yung field capacity na 30%, the permanent wilting point na 11%, the dry unit weight na 1,300 kg per cubic meter, and we have this effective depth of root zone which is 800 mm, and then we have this consumptive use per day, that is 12 mm per day, and then we have this moisture content must not fall below 25% of the water holding capacity between the field capacity and the permanent wilting point. So ano daw yung frequency ng irrigation? So gaano tayo kadalas mag-irrigate, no? So bali dito, given yung field capacity na 30%, and then given yung permanent wilting point na 11%, no? So, di ba may binigay siya na 25%, no? So, bale, kung titignan natin yung available moisture content natin, no? So, we have this 30% minus 11%. So, we have 19%, no? So, 75% of that, yan yung ilalagay natin sa readily available moisture content. So 17% of this 19, we have 14.25%. And the 25% dito for not available moisture content, so 1/4 of this 19% is 4.75%. Okay? So, bale, in terms of depth, so we have this dry density which is 1,300 over 1,000. multiplied by the root zone depth na 0.8, and we have this 14.25%, so that is 148.2 mm. So bali ito yung ima-manage natin for irrigation. So we have this readily available moisture content divided by the consumptive use. So we have a given of we have calculated 148.2 mm for equivalent depth readily available water divided by the consumptive use, which is 12 mm per day. So bali meron tayong 12.35. So say 12 days tayo mag-irrigate na every 12 days. Another example is the following data we recorded from a irrigation field. So given yung field capacity na 20%, yung permanent wilting point at 10%, the dry unit weight of the soil is 15,000 Newton per cubic meter. The effective rainfall is 25 mm. The effective depth of root zone is 1,000 mm. And the moisture content must not fall below 50% of the water holding capacity between the field capacity and the permanent wilting point. So based on the above data, what would be the optimum moisture content and the readily available moisture content? Okay, so bali given yung field capacity na 20% and permanent wilting point na 10%. So bali yung yung total available moisture content natin is 20% minus 10%. So we have 10%. So 50% of this ilalagay natin sa readily available moisture content, and 50% of that is the ilalagay natin for not available moisture content. So bali yung OMC natin is equivalent lang sa minimum balance point. So, yun, no? So, we have 50% or half of this 10% is 5% and half of this 10% is 5%. So, yun yung nakikita natin dyan. So, bali, if we get the equivalent depth of readily available water content, we use this formula. We have 15,000 divided by 9,810 multiplied by the root zone depth na 1 meter, and then multiplied by this 5% for readily available moisture content. So we have 76.453 mm. So yan na yung sagot. And if we want to compute for the frequency irrigation frequency or frequency of irrigation, so we have this readily available moisture content divided by the consumptive use. So we have 148. I think may error to. Ano ayos? May tanong. Wait lang. Ano daw yung optimum moisture content and readily available? Okay, so I think nakalimutan ko na. So anyway, ito na yung sagot, no? We have this optimum moisture content na ito yun, no? We have 20% minus 5%, so we have 15%, or ito yun, no? We have 10% na permanent wilting point plus 5%, so we have 15%. So ito na yung tinatanong niya na optimum moisture content, and ito naman yung tinatanong niya na equivalent depth readily available water, which is 76.453. Okay, so bayan mo na yun, dapat wala yun. Okay, so another example is the present water content. We have 18%, the water content at field capacity, which is 23%, the permanent wilting percentage, which is 9%, the bulk density of 0.3 cm depth surface soil is 1.3 grams per cc. The required is the total water presently contained in the top 30 cm. So we have this formula, no? We have the relative bulk density times the percentage of water over 1,000 times the depth of water. So given yung relative density na 1.3, given yung percentage ng water, which is itong present water content, 18% over 100, times yung depth ng soil, which is itong 30 cm. No? So therefore, yung depth of water natin is 7 cm. Okay, so we have another example here. So, 20 hectare area has a medium texture loam soil grown with wheat crop peak. So, yung daily water use of the wheat crop is 6.2 millimeter per day, and the available soil moisture is 120 millimeter per meter. and the allowable soil moisture depletion is 50%, and the crop root zone is 0.8 meter. The soil infiltration rate is 6 mm per hour, and the other climatic data are the average wind speed na 10 km per hour. The peak demand for wheat was estimated as 6.2 mm per day. They assume moderate climate for an area under consideration and using the application efficiency of 70% of the sprinkler irrigation. So, ano daw yung maximum net depth of water application? Ano daw yung irrigation frequency? Tsaka ano daw yung gross depth of irrigation? So, bali yung mga data na given, we have this area, 20 hectares. The soil texture is the medium texture loam soil. The crop is a wheat. Daily water use of wheat water, the consumptive use is 6.2 mm per day. So, ito yung peak demand ng wheat natin or the peak evapotranspiration. The available soil moisture is 120 millimeter per meter. The allowable soil moisture depletion is 50%. The crop root zone or the DRZ is 0.8. The soil infiltration rate is 6 mm per hour. The average wind speed is 10 km per hour. The irrigation method used is sprinkler system. The climate is moderate climate, and application efficiency is 70%. So, bali ito na yun, no? So, since given yung mads, ito yung gagamitin natin na formula. So, given to, which is 120 mm per meter, multiplied by the, again, given root zone depth, 0.8, times we have this mud, no? So, which is 50%. Okay, the moisture available depletion, no? So, the net depth is 48 mm. Okay, so the volume of water to be applied is we have this area times the D net. So the area is given, we have 20 hectares times 48 mm na net depth, and then we change or we convert yung unit into cubic meters. So we have 9,600 cubic meter. So for an area of 20 hectares, so net application of 9,600 cubic meter, which is 10 by 20 by 48 of water, will be required for irrigation to bring the root zone depth of soil from 50% allowable depletion level to the field capacity. Okay, so yun yun. No? Okay, so for a while. So to compute for the irrigation frequency, we have the readily available moisture content, which is itong 48 mm. Divided lang natin ng peak evapotranspiration natin, which is 6.2 mm per day. So we have a frequency of irrigation na 7.7, say 8 days. And then, so the irrigation system should be designed to provide 48 mm in every 7.7 days. So for practical purposes, the fraction of days are not used for irrigation frequency. Hence, the irrigation frequency in this example is taken as 8 days. Okay. So we need to do some adjustment. No? We need to recompute for the DNet and MAD. So bali yung frequency of irrigation natin is 8 days. So given yung DNet na formula, so therefore we have DNet ngayon na 49.6 mm. So bali yung MAD natin ngayon, using again this formula, we have 52% na allowable deficit, no, ng moisture. Okay, so yan, no? So to account for possible losses of water from pipe due to leakage or from other sources, we need to apply the farm or the field application efficiency from table 6. Bali ito. Itong table na to. Ayan. So, bali yung ginamit natin na irrigation method is sprinkler. So, ito yung gagamitin natin. And we have this climate na moderate climate. No? So, gagamitin ko lang si SCS. So, bali yung field application natin. Application efficiency natin is 70%, though it is given in the problem. Okay, so bali yung D gross ngayon is 49.6 mm divided by 70%. So ito yung D gross natin, 70.86 mm. So ito na yung D gross. So in-account na po diyan ng possible leakage, no? And other blind spot. So bali yung adjustment ngayon. Okay, so the volume of water to be applied, we have area times D gross. So like, papalitan mo lang yung kanina na 48 by 49.6. So ito na yung gagamitin natin, which is 9920 cubic meter. So ibig sabihin, for an area of 20 hectares, yung net application of 9,920 cubic meter, 10 by 20 by 49.6 of water will be required for irrigation to bring the root zone depth of soil from 52% allowable depletion level to the field capacity. So ganun, no? So ganito karami yung volume ng irrigation water na ilalagay natin sa 20 hectares na farm. Okay, so the question arises as to whether the irrigation system should apply the DNET in 876 right down to 1 day, no? This choice will depend on the flexibility the farmer would like to have and his or her willingness to pay the additional cost for different levels of flexibility. So if irrigation is to be completed in 1 day, the system become ideal for remaining 7 days, no? So the cost of the system would be exorbitant. So since larger sizes of irrigation equipment would be required. So on the other hand, for all practical purposes and in order to accommodate the time for cultural practices such as spraying, etc., so it is advisable that the irrigation is completed in less than the irrigation frequency. So in the case of our example, 7 days irrigation and 1 day without irrigation is considered adequate, no? Kasi meron tayong 8 days, di ba? So 7 days mag-irrigate, 1 day wala, no? So adequate pa yan. So the 7 days required to complete one irrigation in the area under consideration is called irrigation cycle. Okay, so next is we have also another example here. Okay, so given yung crop na pineapple, yung depth of soil 0.6, yung soil texture natin is sandy loam, the evapotranspiration or the peak consumptive use is 3.326 millimeter per day. The irrigation method used is sprinkler. The climate is moderate climate. The application efficiency is US, SCS, and assume readily available moisture be approximately 70% of the available moisture, no? So, bali yung gagamitin natin is itong formula or itong table from Israelsen. So, given yung sandy loam natin na soil texture, so bali meron yang IF, infiltration rate na 1 inch per hour or 25.4 millimeter per hour. Given din yung apparent specific gravity natin na 1.5. And given din yung field capacity natin na 14%, permanent wilting point is 6%. So therefore, yung difference nilang dalawa is 8% as our total available moisture content. So ngayon, for the field application efficiency, given yung irrigation method na sprinkler and we have this climate na moderate, so therefore yung field application efficiency natin is 70%. So, given itong field capacity na 14%, permanent wilting point is 6%, so bali yung available moisture content is baliktad to, no? This must be 6% and then this one is 8%. Okay? So, baliktad to, 6% to, and then ito is 8%. So, we take 70% of that. So, 70% aning 6 is 5.6%. And 30% of this 6% is 2.4%, no? So mo na siya, no? So this is for our readily available moisture content to be extracted by plant without stress. And ito naman yung 2.4%. as our not available moisture content, no? Kaya i-extract to ng plant pero under stress na yung plant. So in terms of depth, we have this formula na PA, which is 5.6 ito, divided by 1,000 times the apparent specific gravity, which is 1.5 for Sandilom, and times the root zone depth na 0.6, so we have 5.04 centimeter. So the frequency of irrigation is, we have the 5.04 cm divided by the consumptive use, which is 0.3326 centimeter per day. So we have 15.15, say 15 days yung frequency ng irrigation. Okay, so the D total, we have this 5.04 divided by the frequency of, the field application efficiency na 70%, so we have 7.2 cm. So we have also the D total divided by IF. We have 72 mm divided by the infiltration rate, so we have 3 hours, no, for our time to set the laterals. Okay, and ito na yun, no? So we have this yun na yun, no? So ito yung time of application for one lateral. We have 3 hours. The total depth of water to be applied is 7.2 cm. The frequency of irrigation is 15 days. Ganun, no? Okay, so I think that's it, no? That's the end of basic soil water relation. Okay, so see you in the next video. Thank you.